Why is the sky blue? Why is the sunset reddish in color? These are some questions that we'll try to answer with this demonstration. On my overhead projector, I have a piece of cardboard with an opening cut out in which I can fit a 600 ml beaker. And the size of the beaker is not critical. In the beaker, I have a solution of sodium thiosulfate, also known as hypo. It's about 5 grams of sodium thiosulfate dissolved in a roughly 500 to 600 milliliters of water. What I'm going to do is add some acid to the solution. So I've got some hydrochloric acid here, 1 molar, and we'll add some acid to the solution. Stir that. And then also turn off the lights. Under acidic conditions, sodium thiosulfate will decompose to form a fine suspension of sulfur in the solution. Very, very fine. So we'll see what happens. The apparatus is set up so that I can view both the light coming through the beaker as well as the light then being transmitted through the solution onto the screen here. The reaction speed depends on the amount of acid added. If it goes too slowly, you can add a bit more acid. As the sodium thiosulfate decomposes, it now forms a suspension of sulfur, and you can see that the scattered light is now bluish in color. And that's because as the white light passes through the suspension of sulfur in the water, the blue light is scattered more than the red. And as a consequence, the solution is actually turning bluish in color, and the transmitted light is now reddish. So when we look at the transmitted light, we see that it's now quite reddish in color, and the beaker now is almost white as the light that is scattered is almost completely white light. It still has a slight blue tinge to it at this stage. The transmitted light is now quite reddish, as we see from this. And so this demonstration is also known as a chemical sunset, to show that the sun's color changes as the sun sets. So how does this now relate to the color of the sky? Well, let's consider the Earth with the atmosphere around it. When the sun comes onto the Earth, the sun has to pass through the atmosphere. The particles in the atmosphere will scatter the light. The light that is scattered the most is what we also saw in the demonstration, namely the blue light. And so the light that comes from the sun at all the different parts in the atmosphere is then scattered, and the observer standing somewhere here looks up and sees the scattered light. And the scattered light is then blue in color. And so we have then a blue sky. Keep in mind that the observer on Earth is looking up into the sky and doesn't see the sunlight directly unless you're looking into the sun, but sees only the light that is being scattered by the particles in the atmosphere. Now, in the evening or early in the morning, the sun has to pass through a longer distance in the atmosphere. And so as the sunlight passes through the atmosphere, more of the blue light is being scattered, and what is then coming through is kind of the red light. we actually have two phenomena taking place here. We have scattering, and we also have refraction. So as the light comes in, it also bends a little bit and refracts. The red light is actually refracted a little bit more than the blue, but the main reason is the fact that the sunlight passes through a longer distance in the atmosphere, causing more scattering, and so the observer here sees more of the red colors. During a time when there's a lot of dust in the atmosphere, for example, after a major volcanic eruption, you get more pronounced sunrises and sunsets, because more dust particles scatters more of the light in the atmosphere. At noon, the sunlight comes straight down, and because the distance here is much shorter than when it's coming in at an angle, less light is being scattered. And so the light that we see at noon, for example, or during the day is scattered very little, and so we see basically white light. This is also why smoke tends to have a blue color associated with it. So when you see the exhaust from an automobile, which contains a lot of unburnt oil particles, it tends to have a bluish color, or smoke from a cigarette tends to have a bluish color. And that's because the light passing through the smoke is scattered. The observer then sees some of the scattered light, and the light that is scattered the most is blue. Similarly, when you look at a bottle of skim milk, it tends to have a bluish color associated with it. The particles in the skim milk scatter the light, and what we see is then the blue light that is being scattered.